Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to projectile motion, which is in the two-dimensional motion or motion in a plane category. So previously we discussed the basic introductory concepts related to projectile motion. Here we'll be discussing a specific case and we'll analyze the whole pathway of motion of the projectile motion in this case, which is projectile with horizontal projection. Okay, so here projectile with horizontal projection. Before discussing that, we'll just quickly review some of the basic introductory concepts so that we are clear on what are the things that we need to take care of while analyzing this. So what is a projectile or projectile motion? It is any object which is thrown into the air with some initial velocity and thereafter it moves only under the influence of gravity. Okay, and it does not have anything else to support its motion, whether it's any engine or fuel or anything like that. And the path followed by the projectile, that is called as trajectory. And these are some of the assumptions which are considered while analyzing projectile motion. First, no air resistance, no effects due to the curvature of the earth, no effects due to the rotation of the earth. At all points, acceleration due to gravity or g, small g, that is uniform. And another important thing, which is the most important thing when it comes to analyzing projectile motion because it is two-dimensional motion, and that is that whenever we analyze the motion of a projectile, we have to divide it into two separate categories. First, motion along the horizontal direction, the horizontal component or x-axis component, and motion along the vertical direction, okay, the y-axis component. Every vector parameter which is involved in the projectile motion, let's say velocity, acceleration, displacement, they are divided, they are resolved into their respective x and y components. The initial velocity is resolved into ux and uy. The intermediate velocity and the final velocity of the projectile at each and every point, that is resolved into its x and y components. The acceleration, that is also analyzed separately, acceleration along the x-axis, acceleration along the y-axis. Then displacement, the net displacement, that is also resolved into two categories, along x-axis, along y-axis. Okay, the x subscript, it denotes the following parameter along the x-axis. The y subscript, it denotes the specific parameter along the y-axis. Now, another thing, which is the equations of motion which are applied specifically to each of the two separate axes. We know this is for one-dimensional motion along a straight line. These three basic equations, the same things, they are applied in two-dimensional motion to their respective components, axis components. This is for x-axis, where we have all the x subscripts, and this is along the y-axis, where we have all the parameters, their y components. Okay, this is clear. We have discussed it in the previous video also, basic concepts related to projectile motion. You can watch that. Now, the case which we are studying, projectile with horizontal projection. Let's say we have an object, let's say a ball, a stone, or anything. We are standing on the top of a hill or a cliff or anything. Let's say the height of the hill or the position from where this boy is standing to this point that is, let's say, h. This is the height, okay, h. This is the height from which the object is thrown. Now here horizontal projection means it is thrown horizontally with initial velocity u. Horizontally, not in a oblique manner, not in a angular manner, not like this or not like this. Okay, it makes no angle with the horizontal direction. This is not, this is not. Only straight horizontal direction the object is projected with initial velocity u. So it takes this trajectory, this path starting from O at an intermediate point P and then finally Q. Here let us assign some parameters. Here if we consider this initial velocity, here the initial velocity is acting along the x-axis. So we write ux. So this ux is equal to u, the initial velocity along the x-axis, that is equal to u meter per second, whatever it is, 10, 20, 30 or whatever value it can take. Here the initial velocity has no component along the y-axis. The initial velocity has no component along the y-axis, along the vertical direction, either in this direction or this direction. There is no component. So the component of the initial velocity along the y-axis, that is 0. Okay, these things are clear. Initial velocity. Then acceleration. Acceleration due to gravity is acting downwards. Small g is acting downwards. There is no acceleration in the horizontal direction. Let's say in this direction or this direction. No acceleration in the horizontal direction. So when acceleration is split into two parts, the horizontal component or x component, that is 0 meter per second square, and the y component ay is equal to g meter per second square. Here what sign should we assign to g? Here the motion of the projectile or the object is from top to bottom. Okay, from top to bottom. There we have, this motion can be divided into two parts. Okay, the net motion is like this. Okay, like this. The motion is like this, but we can split it into two parts: the horizontal component and the vertical component. The horizontal component, for the horizontal component, that is the horizontal velocity u, which is constant throughout. It is constant throughout. Until it reaches the ground, the horizontal component stays u, it is constant. But the vertical component, which is initially 0, but as it moves this along this trajectory OPQ, its value increases. How? Because of downward acting G. Downward acting G. The downward acting G, it enhances the vertical component of velocity of the projectile. Okay, that is the Vy component. Vy component. Okay, Vy, the component of the velocity along the y-axis. Vx at any intermediate point, okay, at any intermediate point, we have discussed that the velocity vector is always tangent to the point, okay, tangent to the point drawn at any specific path or trajectory of the motion. We have discussed in motion and plane. So if we take any point here, we can draw a velocity vector like this. We can draw a velocity vector. So each of these velocity vectors will have two components, the horizontal components, the vertical components. Here also it has a horizontal component, a vertical component. This is Vx, this is Vy. This is Vx, this is Vy. So this Vx or the horizontal component, the x component, it stays the same, that is equal to u. Okay, u. Throughout the motion, it stays the same. Initial velocity along the horizontal direction, it stays the same throughout at all the intermediate points. But the y component, which is initially 0 at this point, at point O, the y component is 0, which I have specified here. The y component is 0. We have specified it here. But as the motion goes on, the y component, it starts increasing. And it is because of g. Ay is equal to g. This. It increases. So here, for the vertical motion or the downward motion of the object, acceleration due to gravity is also downward. Motion of the object is also downward. So g is plus. Okay, and there is no acceleration along the horizontal direction. So ax is 0. Okay, and this horizontal component, it remains constant throughout, which is equal to u meter per second. Because there is no acceleration along the horizontal direction, so there is no increase or decrease in the horizontal velocity. There is no acceleration along the horizontal direction, so no increase or decrease in the horizontal velocity. But there is acceleration due to gravity acting along the downward direction. That's why the vertical component By, it keeps on increasing as it goes on and on, like this. Initially it is a bit small, then it keeps on increasing, keeps on increasing, keeps on increasing, like that. Okay, this. Now let us analyze it through the equations of motion and evaluate various parameters. So let's say the object, which is, you have understood the basic the basic mechanics of the whole thing, starting from the initial point to the final point, all the parameters, their values, their directions, how it affects everything. Now we'll discuss the mathematical analysis. Let's say the object, which is initially projected with the horizontal component, only horizontal component u, it moves to point P. Okay, point P, which has coordinates x and y, this. So at this point P, the net horizontal distance covered is equal to x, that is Sx. Remember, Sx, component of displacement along the horizontal direction, along the x-axis, that is equal to x, and the component of displacement along the y direction, that is equal to y. Don't worry about the sign convention now, we are only considering the magnitude. Okay, here Sy is equal to y and Sx is equal to x. Again, here the velocity of the object, the velocity vector of the object at this point P is tangent drawn to this curve trajectory, which is the path of the projectile, which gives us this velocity vector. Again, this is also resolved into two components, Vx and Vy. Vx is equal to u, the horizontal component is always equal to u. It remains constant throughout, always remember this, it remains constant throughout the motion. But this y component Vy, it keeps on increasing because of acceleration due to gravity plus g. I have specifically introduced the plus sign because it is supporting, it is accelerating the vertical motion. Now At this point, the horizontal distance covered Sx is equal to ux into t. Okay, after a certain period of time t, ux into t, simply velocity multiplied with time. Here the x component of displacement is equal to the x component of the velocity, that is ux into t. So that is equal to ut. Okay, or we can write t is equal to x by u. Simply this, x is equal to, it is projected with initial velocity u, which remains constant throughout. So after a certain period of time t, this x is equal to ut. Simply product of velocity and time that gives us the displacement. So this is the horizontal component. Next, the vertical distance y. Again, for y we will use this equation, the second equation of motion, applied along the y-axis. So all the y subscripts, sy is equal to uyt plus 1/2 ayt square. Now here we determined that uy, that the vertical component of the initial velocity, that is 0. So uy will substitute 0. After a certain period of time t, we keep it as it is. Ay is equal to plus g. So we have y is equal to 1/2 gt square. Okay, 1/2 gt square. Sy is equal to y. This is equal to sy. This is equal to sx. And this is the net displacement vector. This one. This is the net displacement vector. This is the x component, this is the y component. Okay, so here sy is equal to y, which is equal to uyt plus 1/2 ayt square. Uy is equal to 0, ay is equal to g. So we have 1/2 gt square. Now here we can substitute this t value also. Okay, t is equal to x by u, which we calculated here. This t is equal to x by u, we can substitute here instead of t. So we will have 1/2 g x by u whole square, which is equal to 1 by 2 g by u square x square. G is constant, initial velocity u, it remains constant throughout. 1 by 2, that is constant. So 1/2 small g by u square, we can treat it as one constant, k. So we have 1 y is equal to kx square. So here this represents that the trajectory of the projectile is in the shape of a parabola. We have proved it through mathematical analysis. Why the shape of the trajectory is in the shape of a parabola? It represents a parabolic equation with constant k is equal to g by 2u square. Okay, so this is very important. Then this is the trajectory of the projectile. Next is the next parameter associated with projectile motion is the time of flight. So the total time for which the projectile is in the air from O to P to Q until it reaches the ground, that is called as the time of flight of the projectile. The time from which it is projected with some velocity until it hits the ground, that is called as time of flight. The time for which it is in the air, okay, that is called as time of flight of the projectile. So let's denote it by capital T. So we have to calculate that. So here we'll be using this equation. Okay, Sy is equal to uyt plus 1/2 ayt square along the y-axis, displacement along the y-axis. So uy is equal to 0. See, uy is equal to 0. Here t we have equated with the time of flight. Okay, the time is equal to the time of flight. This we have substituted t with small t with time of flight. Ay is equal to plus g, we have substituted it here. So we have during the entire time of flight, okay, from the moment it is projected until the moment it hits the ground, for the entire duration of the time of flight, it has covered a net vertical distance of small h. Okay, this from the top of the cliff to the ground, h. This is the vertical displacement during the entire time of flight of the projectile. Entire time duration for which the projectile was in the air, the net vertical displacement is from this initial point to this final point. This is the net vertical displacement h. So here Sy is equal to h, Uy is equal to 0, Ay is equal to g, and t is equal to time of flight. So we have t square. So we can write it as h is equal to 1/2 g capital T square, or we can determine time of flight capital T is equal to root over of 2h by g. So this is another important formula. Okay, another important formula, another important parameter associated with projectile motion, which is time of flight. So again, please pay attention to how we are using for vertical motion, we are using the vertical components, the y components. For horizontal motion, we are using the x components. For horizontal, we are using x components. For vertical, we are using the y components. Okay, this. Next is horizontal range. So horizontal range is the total horizontal distance covered by the projectile during its entire time of flight. So from the moment at the point O it is launched with some initial velocity u to the moment it hits the ground at q, the horizontal distance covered is r equals to yq. The vertical distance h is equal to oy. This is equal to sy. This is equal to sx. Okay, this is the horizontal component of the displacement or horizontal displacement. So r is simply equal to, we can write sx is equal to ux into t. Okay, because s is equal to ut. Here we take the time as the total time of flight duration. S is equal to sx, u is equal to ux. Why? Because the initial horizontal component of the velocity, it remains constant throughout. So that is equal to u into t. U into t. Here we have calculated time of flight is equal to root over of 2h by g. So we substitute that, t is equal to root over of 2h by g. So horizontal range, r is equal to u into 2h by g. This. Again see, 2h by g, it does not have any variable components. These are all constants. Height is a constant, h, it cannot change. Acceleration due to gravity g, that is also constant, it cannot change. So it is a constant parameter, time of flight. Okay, depending upon the height of the cliff and acceleration due to gravity. And u, that is also, it remains constant, the horizontal component which remains constant throughout the motion. Okay, so this is the horizontal range. Simply multiply the horizontal component of velocity, which remains constant throughout for this case, and the time of flight. Okay, this. Then we have the total velocity of the projectile, the net velocity of the projectile at any instant. Now here we have to use these two formulas. V is equal to u plus at. This is the base formula, u plus at. Here we have to split it into two separate components, the x component and y component. For the x component, acceleration is 0, so this whole thing goes 0. The x component, it always stays the same, ux, which is equal to u, this initial velocity, which I have again repeatedly I am saying, this initial projection velocity, the horizontal component, it always remains constant. So that is equal to u. Here we have proved it mathematically also. It always stays Vx is equal to u. The vertical component, that is equal to uy plus ayt. So uy is 0. The initial vertical component, that is equal to 0, which I have told you in the beginning. Uy is equal to 0 because there is no component of this velocity along the horizontal, in the vertical direction. Only in the horizontal direction. It is only in the horizontal direction. No component in the vertical direction. There is no component. So the vertical or y component of the initial velocity, that is equal to 0. The y component of acceleration, that is equal to plus g, because for the downward motion of the object, acceleration due to gravity is also acting downwards. So that's why it is positive. So the y component of acceleration, that is plus g. So final velocity component along the y-axis, that is equal to Vy is equal to uy plus ayt, which is equal to 0 plus gt. So this is Vy is equal to gt and Vx is equal to u. So this horizontal component, it is always remaining constant, whereas the vertical component, it is slowly increasing. It is always remaining constant, whereas the vertical component, it slowly keeps on increasing with time. Okay, gt. As time progresses, this t parameter, as it progresses, it keeps on increasing as this gt, whereas the horizontal component, it is always fixed, it is constant. This keeps on increasing with time. So at any instant, at any of the intermediate points, anywhere, let's say here, at any of the intermediate points, we can use this two formulas, okay, Vx is equal to u and Vy is equal to gt, to determine the net velocity, which is equal to root over of Vx square plus Vy square, which is equal to root over of u square plus g square t square, and this gives us the magnitude of intermediate or final velocity depending upon the position. When the object, it reaches this final point q, it becomes final velocity. Okay, when it reaches the point q, the velocity at this point is called as final velocity. The velocity at this point, this is called as initial velocity. And the velocity at each of these intermediate points, they are called as intermediate velocity, intermediate final velocity, you can say that. Because if we consider any 2 points, let's say this is the initial point, this is the final point, the initial velocity will always be the same. But each of these intermediate points can also be treated as a final point for that specific analysis. Okay, let's say we take any point here, let's say A. So for the analysis of motion from O to A, this initial velocity will always be the same, u, but the velocity at this point Va will be the final velocity for the point for the trajectory OA. Okay, so like this. So the magnitude is root over of Vx square plus Vy square root over, okay, that one, and the angle beta which this resultant velocity vector, okay, the resultant intermediate or final velocity vector makes with the horizontal, that is given by tan inverse of Vy by Vx. So Vy is the y component of velocity and Vx is the x component of velocity. This. So the angle is this. This is the magnitude of velocity. This is the direction of velocity. Tan inverse of Vy by Vx. Vy is equal to Gt. Vx is equal to u. So tan inverse of Gt by u. So again, these two again are important formulas which you can remember if you have to solve questions quickly. If you remember them, it will be good. And I suggest that you remember these formulas because it will be very helpful when it comes to solving numerical problems. There you don't have to do the derivation again and again. You just remember the formula, put the values, get the answer quickly. Okay? This is the thing. So here we have analyzed projectile motion of an object with horizontal projection velocity with no component along the vertical direction. No oblique, no slanting component along the vertical direction. Only horizontal projection velocity. Okay. So another example of this is also in the first video related to projectile motion. We discussed, let's say a package is dropped from a moving aeroplane. The aeroplane is moving with some horizontal velocity. So the packet, when dropped, it will also have the same x component or horizontal component of the velocity at each and every intermediate point. Okay, but the vertical component at start, it is 0, there is nothing, but it slowly will keep on increasing as time progresses as gt. Vy will be gt, Vx will be simply u, it will be constant. It will, and this will keep on increasing with time. Okay, so this is the thing. So here we have discussed the various parameters associated with projectile motion of an object with horizontal projection velocity. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.